is the geosphere. So it includes all the soil, rocks, and minerals present in the crust to the core of the Earth. So from the lithosphere down to the core is what comprised the geosphere. So it is divided into three layers, namely crust, mantle, and core. So if you're going to look at your illustration here, so we have the crust or your lithosphere here, so composed of the crust and the uppermost solid mantle. So we have the continental crust and the oceanic crust. And then we have the mantle, and next we have the outer core and the inner core. So let's talk about first the lithosphere. So there are two types of lithosphere. So we have the oceanic lithosphere and the continental lithosphere. So the continental crust is mostly granite. So the oceanic crust is basalt. Uh, Granite being the um, this is the lighter one compared to the basalt. So basalt is much denser or heavier than the granite or granite. Kung Bisaya mo no, granite. O sige. So, pero social man ta, so granite sa taro no. So granite. So because of this, the less dense continents ride on the denser oceanic plates. So we can see here that the continental crust floats on top of the oceanic crust. Okay? Because this is a bit dense, this is denser compared to the continental crust. Kumbaga, mas mabigat siya compared to the continental crust. So if you're going to look at here, if the two of them will collide at each other, there will be a subduction. Okay, so we call it the subduction zone. So the oceanic crust being the heavier one compared to the continental crust, it will subduct or it will submerge. Okay, so again, oceanic crust or the oceanic lithosphere is denser compared to the continental lithosphere. So when we mention about lithosphere, we also have this particular concept or topic, the plate tectonics. So this is the theory that the Earth's outer shell is divided into several plates that glide over the mantle, the rocky inner layer above the core. So if you are going to compare it, so the Earth is like an egg. Okay, so the plate tectonics or these are the cracks on the eggs. So more of this topic will be discussed later in our topic that deals with the endogenic processes. So the asthenosphere, okay, the asthenosphere, this one here, okay, it is almost solid, although some of its regions could be molten. So characteristic of asthenosphere is it is a part of the upper mantle just below the lithosphere that is involved in plate tectonic movement and isostatic adjustments. So what do we mean by isostatic adjustment? So if example of this is, so our isostasy or isostatic adjustment or movement is, example, you picture this out, a Ziploc bag that is inflated. So if you're going to, example, let's illustrate that one, okay, for better understanding. Okay, so okay, this one. So example, if this is the what's this? The Ziploc bag. Okay. O, di ba? Dudro sa tapanagsa, oy. And then this is inflated. O imagine na lang na inflated. So big on this bloated on this side. Okay, also here and also here. And also here. So if you're going to place a heavier object, say for example a rock on top of this, so it will of course create a dent due to the heaviness or the weight of the rock. Okay, it will push the ziplock, the inflated ziplock bag on this part here, and some portion uh, around the periphery will saan siya will, 'di ba, it will be inflated also at this part here. Kumbaga, mulawom siya dire, it will be due to the weight, but then it will be transferred on this side. Okay? So, the weight that is, the part that is pushed here is transferred on this side here. So, this is an example of what we call as isostatic adjustment. Okay, that's what we meant by isostatic adjustment. Okay, so the tectonic movements and the isostatic adjustments are happening because right below the lithosphere we have the asthenosphere. It is plastic-like in nature. Diba? Ito mga plastic, o di kung say makalugar, dito ra pud sila. Diba? Kapaling-paling. Regards sa atong mga friends nga plastic. Bitaw. Joke lang. Okay, so we have the different layers of the atmosphere. So we have, again, I mentioned already, crust, we have the mantle and the core. And, of course, you have your lithosphere, your asthenosphere, and then we have the mantle here, or we also have the mesosphere. In some books, it's called the mesosphere, and then we have the outer core and the inner core. Now, between these layers, we have the different boundaries, okay, or the discontinuity, okay. So, from the crust or the lithosphere, from the crust going to your mantle, okay, the crust okay, so here we have the different discontinuity. Okay, so the Earth's interior is made of different kinds of materials, as we know it. So each of these materials are different from each other by their physical and chemical properties. So they differ in temperature, in their density. And these unique layers are arranged according to their characteristics inside the Earth. And the transition zones, or we call them the discontinuities, okay, are present. So between, okay, the first one is between, okay, we have here the lithosphere between the crust in your lithosphere. We have the seal, between the seal and the sima. What do we mean by seal? We know that the Earth's crust, or the lithosphere, I mean, is composed of different components. So Cl stands for silicon and aluminum. Okay, so again, the first discontinuity is the Conrad discontinuity. It separates the Cl, or the continental crust, from the sima, or the oceanic crust. Cl, since it stands for silicates, silicon and the silicate minerals, and the what's this, aluminum. Okay, silicon and aluminum. Sima for silicon and magnesium, which is actually the component of our oceanic crust. Next, we have the Moho discontinuity, or we also call that one as the Mohorovičić discontinuity. This is a transition zone between the crust and the mantle. So if you're going to look here, it is at this part here. Okay, your lithosphere, between the lithosphere and the mantle. This is the Moho discontinuity. Okay, transitioning from the upper mantle, between the upper mantle and the lower mantle, we have the Repeti discontinuity. Okay, and then we also have the Gothenburg discontinuity, transition zone from the lower mantle, between the lower mantle and the outer core. And then the last one is the Lehmann discontinuity, transition zone between outer core and the inner core. So if you're going to look at it, there are 5 of them, 5 discontinuities or 5 boundaries. Okay? So those are different layers of the earth. Now let's go